In today's video, I'll teach you what is inside this locally made in Pakistan inverter. So it is a huge inverter. Showing the table, this is a huge inverter. Local Java 1000 watts. This is a local inverter, DIY inverter. There are total 4 screws. 2 screws in these sides, which are missing right now, and another 2 screws on the back side, which I can not show right now. There is a LEDs, inverter LED, charging output LED, charging LED, and fully charged LED. Back side is quite heavy to move. So there are 5 fuses, some alligator clips or thimbles, wire, output socket, and it was 12, give output 12 volt DC, 15 ampere output, input is 10 to 20 volt AC, output is DC. Now this is a breaker in somewhere there, on off voltmeter is missing. Similarly, fan is also missing in the back side. What I tend to do, open the screws. This time I am thinking it's consume a little bit time. So what I tend to do, I remove a screw of camera and then continue the video or still resume them. One screw remove, 3 screws left. I think we need to pause them and open all screws and then continue the video because it is consume time to pause. Now I open the 4 screws for 4 corners. Now see what is inside. It's come out like that. It's something like that. So this is an output transformer. There is 2 MOSFET panels which can IRF 450N. Let me count 1, 2, 3, 4, 5 MOSFET, total 10 MOSFET. So each MOSFET can handle 400 volts, 5 amps of current. So both in fact are parallel. So 5 is parallel and 5 is other parallel. And this is a breaker, a lead indicator, driver charge, and main input. So first explain. So AC those there, utilize the common of the one of the terminal, face those fuse to this wire, and then those to somewhere here to those this wire to breaker, and then those there to this transformer. This is a step down transformer charging a battery, and this controls 12 volt DC, which then those controller to 12 volt AC, which controls by DC by doing this driver and charge the battery. And this driver also generates a pulse, which pulse drives this 5 MOSFET. Each MOSFET has a 5 ampere 400 volts, so all into that 5 MOSFETs that are parallel. So meaning there are total power of 25 ampere each side to drive this transformer. Transformer center tap is connected to a positive of the battery. Will help of the directly to connect the battery. There is a 3 fuse holder. Both are jacked together, so it is not used. So this fuse is totally open. This is open. This is open. And this fuse for power in, and this is a power out fuse, which fuse is connected to the output of the transformer. This is a step up transformer, and this is a step down. This is a step down transformer, 220 to 12 volt converter, and this is a 12 volt, 12 to 240 volt high ampere transformer. Let me share to show you output of this transformer. So if you can clearly see, these are both the MOSFETs. There are both the MOSFETs. Source are connected by this common ground, and where output. Let me. These two sockets is parallel. That parallel to the others. Let me. These wires is all parallel to the others, and then those. There is a control board. There are one rectifier. Couple of capacitors, relay for auto cut off. There are 4 relay, 1, 2, 3, 4, 5, 6 capacitors, 2 presets for battery timing, and rectifier diodes, some resistor capacitor LEDs, and there is LEDs, and these are better. There are basically 1 and 5 148 diodes, 4 diodes connected parallel to drain to source for protecting the self-induction. So basically this transformer will produce a self-induction voltage which is discharged by this set of 5 diodes. One diode number is, and similarly there is also the diode between drain to source to protecting the EMF spike in the reverse bias. And resistor 10 kilo resistor between source to a gate to protect it for automatically transistor turn on. Because it's accidentally transistor turn on, it will damage the entire circuitry. So there is a use of resistor 10 kilo quarter watt resistor which can help to discharge the transistor MOSFET automatically when its circuit is not triggered, similar as top 1. And this is a control circuitry. Let me hide out my cell phone just to show a part number because there are too much dust inside. 5 watt 33 ohm resistors, 12 volt SPDT relays, and some IC and resistors which are totally rusted. And one thing I mentioned to tell, these transformers have different, not only single tap, there are twice of taps. This is a primary taps and standard taps, which is not a single standard tap. I think there are twice of taps. 1, 2, 3, 4, 5 tap. So different taps according to different output voltages. And there is a capacitor cross 2.2 microfarad 400 volts capacitor cross. I mean output, connecting in output for output voltage in volts. Let me investigate a little bit further. All my hand is totally dirty, at this moment because it is quite inside one. Let's see. Now I am totally dust. What is this? This capacitor is connected to the output of this circuit, meaning this is a primary taps and there are secondary taps, twice the winding between secondary terminals, and one of the first pole and last pole is connected to this capacitor, and then these wires to there to a directly output. So this capacitor is basically job that to provide the power factor of this transformer, because this transformer output is a pulsating output. We need a output pure output, so that's why there is a capacitor cross, non-electrolytic capacitor cross outputs. Pure that involves fluctuating into the pure voltage, not AC, pure voltage, which voltage is due to output. So it is that output, not an input. And these transformer, these two wires are connected to this board, and these is a primary input wires. And this transformer are DIY, I mean it's company made DIY transformer, so there is a choice of taps inside output for outputting different voltages. And this is simple little circuit is AC goes in, few subtraction, better for turn on and off, then those are step down by transformer to charge a battery, step down, and then those circuit to charge battery, and once it's battery discharged by this circuit to this MOSFET transformer with the help of the MOSFETs, and MOSFET needs PWM which is done by this circuit, and this circuit transformer and output give to this capacitor which then smooth the output, and then the output go back to the circuit to out. This circuit is, but this transformer is not a single output transformer, it is a multi-stage, like 4-stage I think. And now it's time you might be thinking, what is the circuit diagram of this PCB, which I cannot tell in this video because right now this is in the working condition. So I am made part 1. So to show you how this unit is worked in the future, if I can tear down this thing completely, then I can show you a full part with according to this circuit. There is a 4 relay, 12 volt SPDT, 5 watt 33 ohm resistor, 1.5 kilo ohm resistors, and couple of 1 and 4.7, there are 470 kilo ohm resistor, 10 kilo ohm resistor, 1.5 kilo ohm other resistor, and couple of 1.5 kilo ohm 2 other resistor, 1 kilo ohm resistor, and 2.3 kilo ohm resistor, and 2.2 kilo ohm resistors, and some transistors and some ICs. They use, let me, what I see numbers, HC40 70B, HC40 70B, HC 40 70B. ICs and other ICs, let me check, UA 74 1CN and NE55 timer. So these three ICs used. So I think this NE55 timer IC is used for battery charging system and this relay, and these two UL is IC PWM IC. It is a battery counter IC to drive up MOSFET one by one, and there is a transistor somewhere which I cannot. There is a 10K pot and another kilo ohm pot meter. 20 ohm resistor value is missing. Resistor is missing, I mean. And there is 1 and 4.7, there is one there, and couple of diodes there for protection practically. And there is a capacitor 10 microfarad, 220 microfarad, 1 microfarad, 200 microfarad, and other microfarad capacitor is. And there's 9 volt zener and 9 volt zener is there, and 2 transistor places is missing. Transistor is missing. So I think this board is a company inverter board, and other inverter is a bonding DIY bonding inverter. So this part is a genuine part except of this for entire inverter. And this video is I'm next to you. Pause.